Hi, welcome to the Calculus 2 lecture series. And this is unit number 2. We talk about the techniques for integration. So we are in the lecture number 7. And we talk about the trigonometry integrals. This is the second part of the lecture number 7. And the first part, we talk about the trigonometry integrations involve the function of the powers of sine and cosine functions. So for the second part of the integration technique for the trigonometry functions, we're going to talk about how about the integrations has the tangents and the secant, cotangent, and the cosecant with the power of the tangent and the secant, the power of the cotangent and the cosecant. How do we do that? Okay, so what is the specific things we need to be careful? Okay, so now let's go ahead and go to our lecture series. Okay, so now, so for these ones here, like I mentioned, this is the second part of our section 7.2, talk about the different type of the scale of the trigonometry integrals here, right? So for this integration, we're going to talk about the tangent and the secants. So it is very similar, the strategy, if I have the cotangent and the cosecants here. Okay, so the cotangent x to the n power and the cosecant to the nth power. All right, so I'm not going to have two separate because the cotangent and the cosecant is have the similar property as the tangent and the secants here. Okay, just like we did the first part, let's take a look. In order to do this type of the integration, we have a few key things. So the first thing is here, like we always identify the key identity. Okay, so we're going to talk about the key identities we're going to use. So the key identities here is the Pythagorean identity again. So for the tangent and the secant, we have is 1 plus tangent square x is equal to the secant square x, right? And if you have a cotangent and cosecant, so it is similar. So I know the cotangent square will be equal to the cosecant square x minus 1. Right, so those are the key identities. The first things here, like we did for the part 1. So what are the key trig identities we need to know? Then the second things here, we need to get familiar with, some key derivatives. And those are the very fundamental derivative formulas, right? So the first ones here we need to know is the dx for the tangent axis here. So if the d to the dx, so if the tangent x, you take the derivative, what is the tangent x you take the derivative? Will be secant square x, right? And then the same ways here, if you take the derivative of the secant x tangent x, oh, I'm sorry here. So if you take the derivative of secant x here, right? So if you take the derivative of the secant x, so what is the derivative you're going to have? You will have a secant x tangent x. Okay, so the same way we can talk about the cotangent and the cosecants here. As we remember from our calculus 1, so we know if you are dealing with the cotangents, right? So this will be the similar, like I said, that's why we put these two together, because the tangent secant and the cotangent cosecant, they have a very similar properties. So these ones here, if you said a cotangent x, now what is this one will give you? This will give you negative cosecant square x, right? And then if you take the derivative of the cosecant x, what do you have here? It will give you a negative cosecant x cotangent x, right? So the difference is one negative sign. Okay, so now this is basically this is what we need to do, and then just like we did on the part 1, then maybe we need to do a U sub, right? And then for the for the integrations, so that we need to do the U sub here. So those are the basic skill. So let's take a look. Here is a little bit tricky here, right? So I have, here the m power and the m powers here, right? Okay, so now let's take a look here. If the tangents here, okay? So if tangents here is odd, okay, so that means if it's a tangent 5th power and then second, like a 3rd power, it's doesn't matter, right? So that if it's odd here, all right. So if this is odd, so it doesn't matter what is the n powers here. So what you should do is here, because of the tangents, right? So this is a tangent xn. Because it's odd, you want to factor out one tangent. So you want to do like this, just like we did in the sine cosine. So this is the tangent to the n-1 power times the tangent x here. Okay, so the reason why you want to do that, and then what happens here, this number, so this will be an even, right? So this will be an even. Because this is even, then you can say because the tangent, so we can use the tangent identities, right? So this one, you can really write as the secant square x minus 1. And then this actual, okay, so then this actual tangent, right, you can combine with 1 of the secant. All right, so you can combine with 1 of the secant. Then you will have what? Then you will have a secant and the tangents here. Right, so that means in here, right? So let's take a look. So let's see here, this is a tangent mx and secant nx dx here. So what you can do is here, so you will say here, okay, so you can, this is n-1 x. Cool. Okay, and then the seconds here, you can have a secant n-1 x. So now in here, you have a secant x, tangent x, dx, right? So that's what you kind of get is here, right? So then the secant x, so you take 1 out here. So now in here, you can finally, you can say, you do a u sub. What is u sub will be? Will be the secant x. Why? Because then the du, you will get a what? Secant x, tangent x, dx, right? So that is why, and then you can do the u sub to try to solve it. Okay, now let's take a look at this is the first situation, right? And now let's take a look at the second situation here. So the second situation is, if the n is even, okay? So if the n is even, and I don't care about what is the n's here, right? So now we can factor out. Okay, so now let's see here. So if n is even, so you have a secant x to the n. So you can factor your secant squared n. Then you will have, I'm sorry, not a secant squared n, secant squared x's, right? So you can secant squared x, then you can have the secant n-2, the x here. Okay, so now let's take a look at what's going on here, right? So then in here, you take a look at your integration. This is the tangent mx secant nx dx. Remember we said you can factor out 1, so this is a tangent mx. Then here, this is the secant n-2 x, right? And then you have a secant square x, you factor out the dx here. Let me highlight here. And now you take a look. So because n is even, so n minus 2 is also what? Is evens, right? So let's say, the n minus 2, let's say this one's here is, now given is let's say is 2k, right? So it's some like the even numbers here. Now you will see the reason why, because why here, then the secant square, so I can use the identities here. So this will be the tangent n x, then the in here, then I can put its secant squares, right? So it will be 1 plus tangent square x and to the k's power. Then here is the secant square x dx here. You see here? Okay, so let's make sure. So if I let the n minus 2 is 2k, then this one here is a secant x 2k. You can rewrite this is a secant square x and to the what? To the k's here, right? So now you will see here, that's what is the secant square x here. Okay, so now you can use u sub again. So what we are u subbing here? We are u subbing so here then my u can be what? Be tangent x, right? So the reason why my u can be tangent x, and then this one's here will be, if you take the derivative, du will be what? Tangent, you take the derivative, be secant square x dx. So what is that's what you have this one carried out, right? So then you can use u sub and try to solve this ones here. So this one will be simple u sub will just be, so the u to the n and 1 plus u to the square to the k and the du's, right? Then you'll be able to solve the, solve these integrations here. All right, so then the next situation is in here. How about if you have n is even and you have n is odd? This situation is a little bit difficult, and you probably, need to use the, of course, you need to use the identity, and then you probably need to do the integrated by part to solve it. So this part is a little bit tough, and we also need to get the, for the next topic, when we talk about how to do the, just like the integration of tangent secant by itself, then we can combine it with this situation. So, after you use the identity, then maybe you need to use the integrated by part to kind of decrease the power of those functions here. Okay, so this will be a tough one. It's not that obvious. Okay. And now let's take a look at the problems here. All right, so let's take a look at evaluate the following integration. Okay, so the first thing here, this is the tangent 6 secant 6 here. So for this one here, so both of them is what? Hey, this one is what? This is the even number. And I love the even number, right? So when the, when the secant is even number, that's really good. Why? Because I can say this will be tangent the x to the 6th power. Because it's an even number, I can take 1 secant square out. All right, I can take 1 secant square out. The reason why, remember why we want to take this 1 secant square out? Because I want this become my du's, right? Okay, so now after this one, then you say, okay, this is the tangent 6x, 6x to the 6th power. Now the secant square x, I like that. So this is the 1 plus what? 1 plus tangent square x. right? Then this is the secant square x dx here. So now you can do a very simple. So you say u is equal to the tangent x, then du is equal to what? Secant square x dx here. So we really like the, for the secant x here, the combination, the secant x, if it is even number, that is really easy because then I know you can take a look, you can separate out 1 secant square, and you separate out 1 secant square when you do the u sub, will be very easy u sub. You just u sub tangent, and then the du for tangent is secant square, so you got to take care. Okay, so now let's see here. So this will be u to 6 plus 1 plus u to square du. Right? Did you see how simple this one simplify that? And then you will say this is u to the 6 plus u to the 8 du. So what is here? So this is u to the 7 plus u to the 9 plus c. Right? Okay, now we just simplify. Substitute back my u sub is a tangent, so it's a tangent x to the 7 plus 9. This is a tangent 9 to the x, right? And the plus c. It's pretty cool, right? Okay, so now let's take a look at another one. Right, so for this one, this is a tangent x, secant x. Well, as soon as we see the secant square, we love that, right? So this is good as long as this one is the even number. So that's great because I always can factor that out. So this is a tangent x. So you can do the same thing. So this is the secant square x dx, right? And now the reason why, like we mentioned here, I want this to be my du. And then I can use the identities here. This will be the tangent x. So what is the secant square x? 1 plus the tangent square x, right? And the secant square x dx. Now this will be a easy one again. So I say u is equal to the tangent x. So what is the du? Du is equal to the secant square dx. That's what is here, right? It's good. So my u sub is perfect. So this will be u. This is 1 plus u square du. All right. So see how simple the problem simplify that. So this will be the u plus u cube du. And then your final result is 2u squared plus u fourth to the 4 plus c. All right, so last thing, so what do we do? Substitute back, right? So substitute back my tangent. So this is 2 tangent square x plus 4 tangent fourth x plus c. All right. Okay, now let's take a look at our last problem. Oh boy, this one, I have odd numbers here. Okay, so this is not good. I have odd numbers here, right? So this is an odd number. Okay, so then you see, tangent here is odd number also. Well, maybe I can do is each one I take one, like take one tangent and take 1 secant out. Because I love the even number, I can use identities, right? So I can say, okay, so this one's here, I can say it's a tangent 4x. And this is the secant 6x. Then I have a tangent x, secant x dx, right? So now this is good. Why this is good? Because the tangent secant x, this will be a good u sub. So I know for this ones here, the good u sub, probably I need to set u is equal to what? Secant x, right? Because then the du, so because of this one, so du will be equal to the secant x, tangent x dx. Because of that, so I know I need to replace what? I need to replace the tangent out with the seconds, right? Okay, I need to get the tangent out with the seconds. So now I can do here, the tangent will be what? The tangent will be secant square x minus 1 to the squares, right? Why? It's because this one's because the tangent of force, right? So the tangent of force x is equal to the tangent x to the squares, right? So it's secant square. Then here, this is the secant to the x, and then the tangent x, secant x, the dx, like we talked before. Then I do a u sub, right? So the u sub is u equal to the secant x. Okay, so now my u sub here, so this will be u square minus 1 to the square. Now what is here? U to the 6th. Now what is here? Du, right? It's pretty cool. And now this will become very simple. I just FOIL it first. So u square minus 1. So it's u force minus 2u squared plus 1 to the u to the 6th du, right? Then FOIL it more. So this is u10 minus 2u8 plus u6 du. All right, and now when you take the integration, those will be very simple powers rule. So it will be the u to the 11 minus 9 to the 2 u to the 9 plus what? 7 to the u to the 7 plus what? Plus c, right? Okay, so now substitute back what? My u. So what is my u? Is the secant. So the final answer will be 11 secant x to the 11 power minus 9 over 2. And this is the secant x to the how many power? 9th power. Then plus 7. This is the secant to the what powers here? Secant to the 7th powers, right? Plus c. Okay, so this is our second part. How do we deal with the combinations for the power of the tangent and the seconds here? So, like we said, one thing we like it, is as soon as the secant is even, then that's set. That's very easy. And the seconds here, if the secant powers here is odd, if tangent is also odd, that's perfect, right? So you can just take one out for each. So the reason why I said if the secant is odd and tangent is even will be a little bit difficult. The reason why, so if you change these ones here, so these ones here, if I change this is to the 4 theta, 4 theta here, and then this is the secant to the 7 theta, d thetas, right? Oh, here. Oh, I use the x all the way. So let's treat this as x, so okay, so if this one's here, you said the secant, the 7x dx. Okay, so if this is the situation, well, you still can, you say, okay, how about I want to separate the one secant out, right? So you said this is be a tangent 3x, secant 6x, right? So then you take out a tangent x, the secant x, the dx here. Well, this one, you still can have this one as the u, right? So the du. But the problem here is a tangent cube. So because it's a tangent cube, you cannot apply the identity. So you might need to use some other method like integration by parts or some others, so this type of problem is kind of will become way more complicated than what is the basic, the trig substitutions here. All right, okay, that's it. Nice talk to you about this one. So our next part 3, we're going to talk a different situation again. All right, talk to you. Okay, talk to you later. Have a good day. Bye.